do put your questions into the chat window. We're going to hand off now to Laurence Gill and Joanne if she wants to share her video or audio, and then we will get to the questions at the end. But be assured, if you have to leave the meeting, the training before the end of this meeting, if it's in the chat window, somebody will get back to you, and we will take care of that for you. Okay, take it away, Laurence. Be sure and unmute yourself.
Yeah. Hi, everybody. Can you see that as a full screen, as a presentation? Yeah. Okay, great.
Yes. Yes.
Yeah. I've got too many screens here. I'm trying to work out which one.
Yeah. I'm actually seeing your screen, your presentation, but also the next slide.
Okay. Yeah. That wasn't the one I wanted.
Laurence, you need to change your display. There you go. Yeah.
Start again. Is that better?
Much better. Thank you.
Right. Okay. Yeah. So my name's Laurence Gill, and I'm Professor of Environmental Engineering in Trinity College Dublin. So Trinity College Dublin is the oldest university in Ireland, and I want to talk about a research project that we did, sponsored by the EPA, Environmental Protection Agency in Ireland. So Joanne, who you can see the picture, is here. Joanne did the research on this, Joanne MacMahon, so she can answer any difficult questions at the end. So I think, like the talk's been set up very nicely, both by Richard, who's described the existing situation in Ireland in terms of percolation testing and on-site site assessment, and then Kelly's done an excellent job in going through all the theory, so I'm not actually sure I need to give my talk, but I'll go through it anyway. Yeah, so for many years, about 20 years now, I've been doing research onto on-site systems, and we typically construct full-scale field sites and monitor them over several years. And one of my main interests is how different contaminants move through the soil into the groundwater, through groundwater, etc. And the way in Ireland we sort of define, if you like, the percolation characteristics of a site is via a falling head test known as the T test. And so these T values that Richard described are used really as the main way of describing the site. Now, I'll get back to how we do a proper site suitable assessment. But over the years, a lot of our research has fed into the development of the code of practice, the first one and the second one. And so a lot of the thresholds for when you can use a certain type of treatment system, a septic tank versus maybe a packaged treatment system, etc. Some of those thresholds have been determined by work we've done on sites, on a limited number of sites. We've done a lot of work on how the contaminants move through the soil, etc. But there's still one or two sites, and we've characterized them according to these T values. And I've become quite uneasy about this over time because of the limitations of these falling head tests. Extrapolating that data for many different soil types, I'm not so sure is a very rigorous thing to do, particularly when you're looking at these kind of threshold values. So anyway, over time we've kind of realised this, and we've made talked to the EPA about it, and we've done a series of different research projects, ending in this one to see, is there a better way of assessing the percolation characteristics of a site than the falling head test. So I'll run through the project. Is that me talking? Am I getting feedback? Sorry, I'm hearing a voice coming back.
Yeah, we were getting a little bit of feedback from you.
Okay. Well, hopefully you can hear me. So anyway, that gives a kind of background. So I'm going to run through the research we've done for the EPA and what our recommendations are, and whether they'll take it up or not is kind of up to the EPA, I guess. Just the project background. So as Richard has talked about, we have this test known as the T test, which is a 400 mil deep hole, 300 by 300 square hole. You fill it full of water the night before to pre-soak it, come back, fill it up to 400 mils, and then you let the water drop, and then you start timing it from it dropping from 300 to 200, and you do that 3 times, take the average and divide through by 4 to give you the 25 mils, the inch, and that gives you your T value. So a low T value means very fast percolation, and a high T value means very slow percolation, which straight away adds to confusion, I think, for some people. If you come from more of a environmental engineering, soil type background, hydrology background, it's the other way. Generally a low value means very slow, very fast percolation in terms of KSAT. So you have these tests, and then we have certain threshold values. So the fastest is a T of 3. Is the kind of cutoff point in terms of soil being too fast for, say, septic tank effluent, and then we got various ones in the slower soils, T of 75, T of 90, and then more recently it's gone up to the sort of slowest soil, if you like. You can put a system on with drip irrigation is T of 120. And I think one of the confusing, another thing I'm not happy about with the T values is that this shift from, say, T to 90 to 120, people seem to feel that this is a big jump, but in reality it's a tiny difference in terms of actual percolation capacity, if you like, in the soil, because of the way the T value is measured, and I'll show you that in a graph. So it gives a very false view, I think, of what the soil's really doing, or how much water can percolate through it. So we have that, and we have these threshold values, and then we have the as part of the site assessment, you have to do the soil texture classification, as Richard showed you in the charts. So you dig a trial hole and you assess your different bands. Just to make the point, in Ireland we have a lot of I suppose similar to what Kelly was talking about in Canada, we have a lot of glacially derived soils, particularly more in the north of the country. The sort of glaciers came down about halfway down the country, dumped a load of soil. So we have that similar type of characteristic. We have a lot of very low permeability soils as well, covering the country. So anyway, so you do the soil classification, but the way we classify the soils, it's not according to, say, the USDA 12 different soil categories. We do it according to the British standard 5930, which really is an engineering standard. So it's more from a sort of, it's been developed really more from a sort of geotechnical perspective. So I'll come on to show you this, but it's not, doesn't have fine enough resolution really, I think, for what we're trying to do when we're assessing a site in terms of soil percolation. Now it is there, and you have to assess the soil texture, but then when the site assessment is handed in, if you like, it's not really as part of the decision-making process. Really, you're looking at these threshold T values. Now, everybody will say it is, but I think the reality is it's used as a kind of secondary check, really, possibly, by the local authorities just to make sure that you've done the test correctly. So, if you've got a clay subsoil and you give a very fast percolation value, someone would sort of say there's something up here. But I have the feeling that it's not, it's not used in anger that much. People really focus on these numbers, the T value, rightly or wrongly. So anyway, but the key thing is, there's a lot of experience and empirical work that has gone on to define these threshold T values across the country, and research, for example, research we've done, for example, and we need to build upon that rather than just sort of throw it out, as it were. So the falling head test, as Kelly's mentioned, is being under increased scrutiny, and people who have actually done research into this area, the impression is that they think we should be moving away from the T test for the reasons Kelly went into. And if you're going to do a field percolation test, then a constant head test is a more rigorous way to assess this, and because it's a unique, as Kelly mentioned, it's a unique soil property, and therefore you can compare. It's not it's not linked to the size of the hole, the head, etc. I mean, the equations take care of that, and then you can compare values across different soil types and across different jurisdictions. So what we were trying to do was to first of all, we did a sort of review, or Joanne really did a view across globally across different methods that have been used, and how do people estimate percolation characteristics of soil. So on-site falling head percolation tests, which are still used in many jurisdictions, many different countries. On-site constant head permeameter tests, and then other methods like soil texture, particle size analysis, etc. And then what we wanted to do was try to come up with, we have these T values, these threshold T values, and so we wanted to try and come up with an equivalent field saturated hydraulic conductivity from constant head tests to the T value. So if this was brought in as a method, we could define what these thresholds would be, and maybe have the two tests in parallel for a while, or maybe it replaces the T value, but at least build on that previous knowledge of where we think these boundaries are, the different sort of treatment systems, etc. So we did this via a combination of numerical modelling, which I'll describe, and then we did some parallel tests, falling head tests versus constant head tests on a range of different Irish soil types. So if first we'll get to the modelling then. So over the last 15 years or so, I've been collecting a database of different T tests, these falling head tests. A lot of these I've done myself, or they've been done by people who I would trust, to characterize the texture of the soil properly and to do the test. It's I think now in Ireland, over the last 10 years, there's been a lot of effort in terms of training people to do proper site suitability assessments. Before that, I think it's fair to say it was fairly unregulated, and a lot of those tests would be a bit questionable. I think some of the results. So this database, I'd be fairly happy with the characterization of soil texture, and also the values, the T values. So from that, we then took the inner 50 percentile. So we got rid of the sort of top 90, 25%, and bottom 25%. And across a range of different soil types, we started to model each one of these using this computer software, Hydrus, which is a finite element model. I presume some people are aware of it. It's very good at modelling unsaturated, variably saturated flow in soils, and it's based on the Richards equation. So what we did then for each one of these 400 tests, we had the values, so these dots on this graph are when it hit 300, when it hit 225, etc. As many reference points as we had, and then we adjusted the saturated hydraulic conductivity of the soil in this system to match, and we tweaked that around until we got it to match that test, and then that was the KS for that particular soil type. And in total, this is what we ended up with then. So this is the sort of 400 odd tests. So you got the KS values that we found from the modelling versus what the actual T value was measured on site, and then you can see the different. These are the British standard classifications. So you got a sand, silt/K, and a clay. And so, as expected, the sands are with the very low T values had the high KS values, and the clays give you a much slower K-sats, but which equates to a higher T value. But you can see if this is plotted on a linear scale, it gives this very very kind of flat profile at the end here. And this is this problem, why the difference between 90 and 120 is very, very little in terms of actual KS or KSAT. So anyway, from this, I've now plotted this here on. It's the same data basically on a log scale, and then we fitted a best fit line through this to give this relationship between this range of Irish soils, and from the modelling, what the relationship between the saturated hydraulic conductivity is, and the T value as measured according to our dimensions, our holes in Ireland. So that's that, and I'll come back to that in a minute. And then the next thing we did then is we went out onto different sites, and we tried to pick sites of different soil texture with different percolation characteristics. And we did a parallel t-test and a constant head test, permeability test. We used the aardvark that was mentioned earlier, just because I like the name. Maybe Kelly, you should rename your device after some obscure mammal from my syllable. But anyway, so I can't remember. No, I met someone at a conference who was talking about this, and that's why we went for the aardvark. But anyway, hopefully these as I said, these different. It's not really dependent on the device that you use. If you use the equations that I'm going to show you, in terms of defining the KS value, KFS value. So on these different sites, we did the t-test, got a t-value, and then a certain distance away, we did our permeability tests and got the values, and then we started to so different permeabilities will, if you, well, certainly the other, it gives you a certain equation to use to define the KFS. But we decided to look into different methods of how do you use that data. So as Kelly defined, you set this up, and in this case, this pressure regulator maintains a depth of around about 10 centimeters head of water in here, and initially the water flows out of this reservoir, and you're measuring the volume change, every 10 minutes, maybe something like that. And initially you get quite a fast infiltration of the water as it's establishing this saturated plume underneath, and then after a certain period of time it starts to stabilize out the infiltration, the flow of water per unit time. And once you get about 3 of these that are consistent, then you take that as your infiltration rate, and then this plugs into these equations, and you also need the radius of the hole and the depth of the hole, and in some cases some other aspects. So anyway, what we did then, we started to look at different ways of using this infiltration rate to define what the KFS is, so the field saturated hydraulic conductivity, because this has been done in the field with an unsaturated soil beneath the plume. And I'll show you the results. So yeah, so the different permeameters provide their recommended equations to solve for KFS, and I think Kelly's gone through this fairly well. So there was the original Glover solution, which only accounts for the saturated flow, and then there's the Glover solution adjusted for gravity, and then there's this Reynolds solution, which I think Kelly, this is the one they ended up using. And for this one, I mean, there's these different parameters. So this capillarity alpha parameter that these different Z parameters you can put in depending on how you define the sort of texture of your soil. Now I'll come back to this, but from what we did, we tried all the different equations and these different sub equations, if you like, from this one, and we found this alpha of 12, this in meters per day, so it's 0.12 centimeters that Kelly was talking about, gave us, for most of our range of soils, actually gave us pretty good results. So so what this graph then is showing, the green curve is our curve we derived from the modeling versus the 400 different tests. And then for each one of these sites, so we had 17 different sites where we did the falling head test to define the T value, and then we did the permeability test, and we solved using these different equations. We solved for what the KFS, what that would give you in terms of KFS, to see how that matched. So what we found is the Glover solution was found to estimate higher KFS values when applied to the field tests, which that that was stated. I think Kelly said that actually as well, and that was maybe possibly no surprise. And as I mentioned previously, the one we found matched our curve the best was this Reynolds 2008 equation using this alpha of 12 for most of the soils. So this is the black dots or the black crosses on that curve. So we felt that, you know, going forward, that would be the best match, if you like, to derive a KFS from the T values. Now, the other thing, and again, Kelly was talking about this, was to correlate the KS values or KFS values and the T values. So, as I mentioned, in Ireland, we have these thresholds, these you know, T equals 3 down at the bottom end, T equals 50, T equals 75, T equals 120, etc. So what we want to do is to try to define what are those threshold points if we were going to transition to using the permeameter test. So in terms of the KFS value. So there's been, you know, different attempts over the years. So this one by Mulqueen and Rogers. These are two guys in Ireland. So again, they were looking specifically at our t-test shaped hole, and they came up with this relationship, which again shows this issue to do with the t value, how sensitive it is down at very low KFS values, and then more recently, most recently, there's this Dan Reynolds, who's spent his life looking at this, has come up with this unified theory from which you can kind of interchange between the falling head tests and constant head tests. So we looked at these comparisons, and I mean, I suppose ultimately it looked like this Reynolds this method that to convert between t values and equivalent KFS matched our data the best. I don't really need to go into this too much, but so what we were, in some cases, we were taking the KFS value from the Hydrus model and converting that into t values, and in other cases we're converting the t value back into KFS values and looking at different ways to do it. But fundamentally, we found that this Reynolds approach seemed to work the best for us. So from that, then we can sort of hopefully define better what these t values are in terms of these thresholds, and you know, hardwired into the code of practice in terms of KFS values. So looking at that, then this is the what we found. So oh yeah, sorry, just to confuse things a bit more. So I was talking about t values. So up until a few months ago, that's what we called it, a t value from the t-test. Now the new code of practice has changed terminology to PV value. But that's the same. That's the same as the t value. So for fast percolating subsoils, sandy soils, the threshold is 3. So that's 3 minutes percolation for 25 mils for an inch. And from the work we've done, we reckon that equates to a KFS of 102.7. So I've got it in centimeters per day. I kind of agree with Kelly in terms of choosing the right units to keep the numbers kind of reasonable that people understand it. So you know, we could obviously put that in millimeters per day. That'd be just over 1,000. Then another. So you can see on the right hand side, this is from the code of practice. This is the sort of rationale, if you like, for these different threshold points and what it means. So anything between 3 and 50, t value of 50 is good for a septic tank with kind of relatively standard soil treatment area, percolation area, and so this is the range in terms of the KFS values. Up to 75, you can so by up to 70, again I'm getting stuck in this terminology. going down in percolation, if you like, to a T-value of 75, that's lower percolation than 50, then you can use secondary treated effluent going into the soil. Up to 90, then you can use tertiary treatment effluent effectively before it goes into the soil. And then we have this threshold of up to 120 T-value of down to 120, really more accurately I should say, which goes down to a KFS value of 2.8, where you can have secondary treated effluent going into soil, but into a drip dispersal system where we're getting the benefit of evapotranspiration, etc. And if the percolation, if the permeability of the soil is less than that, around about 3, then it's just not suitable. The soil wouldn't really even be able to take the rainfall, let alone additional effluent load. So this is a kind of translation, if you like, that we would be recommending. Joanne's prepared this constant head test calculator where you basically put the numbers in and it does the work for So again, you don't have to sort of worry about, as Kelly was saying about doing the sums. You put your values in. The height, the depth that the permeameter maintains the constant head of the radius of the soil, and then the constant kind of flow rates, and you can choose which particular of these alpha values. Like as I say, we were recommending this middle one, and then it will give you a KFS value, and then it will give you an equivalent PV value as well. So that's kind of what we're recommending. And just to say that we also did a comparison of some of these KFS values across different jurisdictions. So some in America, some in Australia. So that's the Australian and New Zealand standards, some in Canada. CEN is the European recommendation. So what I've done here, this is for the bands for this British standard, gravel, sand, silt / clay, and clay, and shown what from our data of say the 900 sites, what broadly we reckon the range is in terms of the PT value, or the T value, what that equates to in terms of the KFS, and what other people have defined their KFSs are to so we can kind of compare against them. So some of the limitations then and the conclusions from the review is that it seems that as has been stated, there's no real perfect method of evaluating the KFS, and some jurisdictions place emphasis on percolation tests, others use just soil texture, and others use a combination of it. I mean, we again, as Kelly said, we believe a combination should be used, but if you're going to use an on-site percolation test, I suppose our conclusion was the constant head test is a much more rigorous way to go, and we feel we've provided some kind of translation, if you like, between the numbers in the code of practice from the t-test PV values, and if you started to use these permeameter tests. So yeah, I think I've kind of said that. So so this is the review across different countries, etc. And as has been said, I mean, I think that the feeling for a lot of people who have studied this in detail is that really that you need two methods really to mitigate the risks of outlier results. So some sort of soil classification that actually means something that is used in anger, if you like, in the decision making process, and some on-site percolation test, preferably I would believe a constant head test. But that's part of the picture. I mean, if you're going to, the whole site evaluation is also critical in terms of as most people here know, that the slope, etc., the depth of the subsoil, there's a lot of other factors that go into the final system design. So in conclusion, then we feel that in certain places around the world there has been a lot of emphasis on this, and people have moved away from the falling head test, or as the sole method of estimating the permeability of the subsoil. and soil texture classification can act as a critical check of the percolation test results, as it does in the Irish Code of Practice at the moment. I mean, that's the way it's used, but I'm not so sure it's. I think the final decision really is based on these numbers from the t-test. We felt for our particular, we use this British standard system for soil classification, which is not ideal by any means. As I say, it's really developed as a geotechnical structural, for structures, etc. Methodology of classifying soil, and it doesn't really have the fineness, gradation, if you like, to be able to be used properly, I think, to assign robust bands for soil permeability. We felt that from the constant head test, using a permeameter test, and you should use this Reynolds 2008 solution, and we've provided from this, I suppose, this database and using the hydros modeling, this trend line that we developed, this translation between the threshold T values and KFS that then you would derive from this test. I mean, going forward, I mean, for a start, it isn't legislation at the moment in Ireland. Hopefully, this project will convince the EPA to bring it in. If they do bring it in, then obviously we need to do. I think the more data we build up and have this properly logged on a database of people, site assessors going out there, get their results, how are they classifying the soil, etc. So the more data we build up, the more we can refine the relationship. Etc. So anyway, so hopefully that gives a flavour of what we've been doing. As I say, Joanne's online here as well, so we're happy to answer questions about the research we've been doing. This will be there's going to be an EPA report published soon. I'd say within the next 2 months probably. They're still kind of reviewing it and we're tweaking around with it, but there'll be a proper report that comes out on this, and I can send it to you. Okay.